So we are getting to the last lesson in module 9, and this one, lesson 9.6, is to simulate chance events. And learning target, I can design a simulation to represent a simple or compound event and use the results of a simulation to find the experimental probability. The vocabulary that we are going to be learning is simulation. Okay. And what is simulation? Simulation is an experiment that is designed to model one or more events. And simulations often model events that can be difficult, time consuming, or impractical to perform in real life. Okay. Suppose a cereal company, it says that there is a prize in one out of three boxes that you are buying. Okay. So suppose it's like it's placing a prize in one out of every three of its cereal boxes. You can design a simulation that models whether or not a box of cereal you buy will contain a prize. Okay. So, we're going to look at this, and I am going to model using a spinner, and I'm going to model using a number cube. Okay. The event consists of randomly selecting a cereal box to simulate the event. You can design an experiment that has the same probability of success. All right, so it has the same probability of success. And in this case, the probability of success is one out of three, because one out of the three boxes contains a prize. Okay, so one way you can design a simulation is to design a spinner that has the probability of a successful outcome as one third. So in this case, the spinner will have three equal size sections. So I've created this. Each of them, it is one third, right? And so there is equal probability of landing in any of these when it is spun. So therefore, I'm creating this. It'll have three equal size sections. And in this simulation, a success is defined as the spinner landing on blue, because we said one out of three. So I've just made this spinner. So if it lands on blue, there's going to be success. All right, because that is one out of the three. And that represents selecting a box with a prize. This one, the blue is representing box with the prize, because the prize is in one out of every three boxes. All right. And a failure is defined as the spinner landing on red and represents selecting a box without a prize. So two out of three is the probability of failure, right? Because the prize is only in one out of three boxes. So I can represent by the spinner like this, and I can simulate that event. All right. Another way that I can do this is, I can design a simulation is to use a number cube. Okay, number cubes are normally they are like 1 through 6, and because the number cube has 6 sides, I'm going to rewrite the probability, which we said one out of the three boxes is going to have a prize, right? So one out of three boxes is going to have a prize. So I can design a simulation by writing an equivalent fraction with a denominator of 6, because I know that the number cube has 6 sides. So I can easily do this. I can rewrite this as 6. So this would represent my 6. All right. And I know that 3 times 2 is 6. So 1 times 2 is going to give me 2 out of 6 faces will represent selecting a box with a prize. Okay. So in this simulation, success is defined by rolling 2 of the 6 faces and represents selecting a box with a prize. And failure is defined by rolling 4 of the 6 faces, represent 6 faces, and represents selecting a box without a prize. You can determine which two faces are successes. Suppose I decide that in a number cube, my rolls if it falls on one or if it falls on two, that is going to be my success. Okay, or that is going to be the cereal box with a prize. So what roles are going to then, so if I'm saying one and two over here, because we know that a number cube has six sides. So if I'm saying that one and two, if I roll one or two, because two out of six is going to be my one third, and I know that one of the three boxes has the prize. So if I say one and two are representing the two, and that's the success of the prize, then what is the not success? Or not going to be successful of, or what is the failure uh, of finding the prize? And then that would be three, four, five, six. So four out of six would be where I do not find the prize. So this is how I can simulate that event. Okay. So I am now going to show you this table, and I'm just going to give you an example. Okay, here are some examples. And based on this example, we are going to see a couple of things. All right. So we are going to simulate each event by placing an X in that column. So there are five different events that we can see. Okay, one, two, three, four, five different events that we can see in this table. And we're going to choose the model that can be used to correctly simulate each event by placing an X in that column. Okay, so let's look at this. We've got an event, we are trying to simulate it, and which of these methods can I use? So we've got a spinner with four equal size sections. We have four equal size sections, okay? And then we have a coin toss. And I know for a coin toss, you can only have two outcomes, heads or tails, all right? So let's look at these events and think about which one can I use for simulation in this context. So the first one, your favorite book out of your four books being randomly assigned for a book report. So, when we're talking about four different books, obviously we are going to need four equal size sections. So, then therefore, this one would be the correct choice. Okay, so this one would be the correct choice. Spinner with four equal size sections. Let's look at the second one. Your favorite baseball team has three out of four probability of winning. So we need four different sections. So we are definitely going to choose the spinner with four equal size sections in this case. All right, let's look at the next one. We have a 1/2 chance, a one out of two ratio chance, a girls soccer team wins its first game. So since there are two options, the coin toss would be great, because in a coin toss you have the probability either heads, tails, so there are only two choices. So because of that, in this one I would use this for simulation. All right. A forecast shows a 50% chance of rain. So 50%, 50 out of 100, which is 1/2. So 50% chance of rain, 50% no chance of rain, right? So therefore, we just need two options over here. So for this, the coin toss would be the best way to simulate that event, right? And then let's look at the last one. A marble is randomly chosen from a bag containing four different color marbles. Now, again, we need four different sections because we're talking about four different colored marbles. So, because of that, I would choose the spinner with four equal size sections. So, just an example of how I can create a simulation, and a spinner or a coin toss or a number cube. These are all great ways to create to create a simulation or to simulate chance events. Okay, so let's quickly discuss. I am going to just take you to the board over here so that you can see the question, so that we can design a simulation. All right. So, as with simple events, you can design a simulation to simulate a compound event. And as I said, coins, number cubes, and spinners are often used to simulate events. To design a simulation, you need to do each of the following, okay? So you need to define what each outcome represents and determine if it is a success or failure, and then define what each trial represents. So let's look at this question over here. We have to design a simulation. All right. So suppose each tiger cub born in a litter of cubs has an equal chance of being a female or male. Okay. Suppose each tiger cub born in a litter of cubs has an equal chance of being female or male. And in a litter of 3 tiger cubs, estimate the probability that all 3 cubs will be females. Okay, so let's look at this. The step one, I do have to design a simulation. And for each cub, there are 2 possible outcomes. You can have female or you can have a male, right? So since it's just 2 options, what would be the best way to design a simulation is to toss a coin, because a coin has 2 possible outcomes. Okay. And because there are 3 cubs in the litter, each trial represents tossing 3 coins. You can choose to let heads represent a female cub and tails represent a male cub. Okay, so heads again female, or we can have tails, which is representing a male cub. So in order to perform the simulation, suppose I have a table which shows the results of 100 trials after the simulation. So let me just go ahead and show you the table, and let's say this is what I get. Okay, so this table is showing the results of 100 trials of the simulation. So these are the outcomes, and this is the relative frequency. 3 females and we got 0 males, 14. 2 females, 1 male, 33. 1 female, 2 males, 41. 0 females, 3 males, 12. So that's the relative frequency that we got after 100 trials of that tossing the coin. Okay, so if I add up all this is 100. So now I'm going to see what was the question. The question was asking that, you know, what will happen if we can estimate that all 3 cubs will be females. So let's look at the relative frequency of 3 cubs being female, and let's see if the experimental probability, which has the same ratio as the relative frequency. Okay, so once we did that, what did we see? We got 14, right? Because 3 females. So for the simulation data for the 100 trials, 3 females, 0 males, my frequency is 14. And so 14, which is out of 100. Okay, so 14 out of 100. And so then what am I going to do? I'm going to simplify it. And when I simplify that ratio, I divide by 2 and I get 7 over 50. Right? So if I simplify that ratio, I get 7 over 50. And then based on this simulation, what is the estimated probability that all 3 tiger cubs will be female? 7 over 50, what is that? That's nothing but 14%. Okay, so if the answer would be 1400, it would be 7 over 50, or it would be, so here we go, 1400, 7 out of 50, or 14%. So based on the simulation, the estimated probability that all 3 tiger cubs will be female is what we just calculated. That is 14%. Okay, now I am going to give you some scenarios. And I'm going to just put the question up here so it's easy for you to see and refer back to if need be. But I'm going to give you a couple of scenarios, and then we can decide how to simulate that event. Okay, so let's look at this one. Again, there are many ways to simulate compound events. Some examples I'm going to show you now. Okay, Suppose that during the springtime it rains 50% of the days. What is the chance that it will rain 2 days in a row this spring? Okay, so days in a row. So I'm just going to show you by pulling up what I can do, because it's talking about 50%, that is 50% raining, 50% not raining. So best thing, we can either use a coin toss, okay, or we can also use a spinner. So if you look at this, okay, try to get this out of the way. Okay, all right, so let's look at this one. So coin toss, let heads represent rain, let tails represent no rain, because we know that the possibility of rain or no rain is just two different, uh, outcomes that are there. So because of that, a coin toss would be great. Okay. So each trial consists of two tosses of a coin, because we're talking about rain in 2 days. Okay, so two tosses of a coin, and a successful event is represented by tossing two heads, because we said let heads represent rain. Okay, and then whereas the spinner is concerned, I can have four sections with equal sections of rain and no rain. So each, as you can see, is 25%. It's four different equal parts, two with rain, two with no rain, and each trial consists of two spins, and a successful trial is the pointer landing on rain 2 times in a row. So this is a great simulation of weather. All right, let's do another example, and here's one, and let me try to, there we go. All right, so here is one where we have marbles that we're talking about. And suppose you have a bag of marble with an equal number of red, blue, and green marbles. So now that means we have three different colors. Okay, what is the probability of randomly selecting a red marble from the bag 3 times in a row with replacement? With replacement means the marble, once it's picked up, it is put back in the bag. If it was without replacement, if I remove it, it is out. And then whatever I'm left with, from that I'm selecting. But it says with replacement, that means I am putting it back into the bag after picking that marble. Okay, so there are two good ways to do this, because there are three different sections. We can use the number cube. All right, and so because number cube, basically, what does it have? It has out of 6 parts. So what we can do is we can have two unique numbers over there to represent red, and each trial is going to consist of rolling the number cube 3 times, and the success is landing on the two specified numbers. Okay, the two specified numbers 3 times in a row. Okay, so 3 times in a row. Let me try to pull this up so you can see this a little better. There we go. All right, so let's say I chose 1 and 2 on the number cube to represent, red. So if it lands on 1 and 2, it's a success. If it lands on 3, 4, 5, 6, it is not successful. So that's basically what this is. Okay, and then we can use a spinner. As you can see, I have green, red, blue, 3 different sections. A successful trial is the pointer landing on red 3 times in a row. Okay, so because we talked about 3 times in a row with replacement for both of these, landing on the two specified numbers 3 times in a row, and same thing over here, 3 times in a row. So this is a great way to show simulation. All right, now let's talk about another example so that you understand how we are creating the simulations. Let's talk about a football. Just do this. Okay. So suppose that on average, a professional football kicker makes 2 out of 3 of his field goals from the 40-yard line, what is the probability that he makes 2 field goals in a row? Okay, so when I look at this one, we are going to assign four. So we're going to use a number cube and a spinner again in this case, because it's talking about 2/3. So in a number cube, I can definitely use that, my equivalent ratio, because in a number cube, I have out of 6. So I can do that over 3. Okay, and we know that 2 of them uh, are going to be now failure in this case, and 4 are going to be successful in this case, because we are talking about 2 out of 3 of his field goals from the 40-yard line. So we're going to assign 4 of the numbers on the number cube to represent the success rate of 2 out of 3, because 2 out of 3 is what? 4 out of 6. All right. So let's say the first 4 numbers in the number cube are representing the success, and each trial consists of rolling the cube twice. And a success is represented by landing on any of those assigned numbers 2 times in a row. So as I said, 1, 2, 3, 4 on the number cube. Let's say the first 4 are representing success. So if it lands on any of those 4 numbers 2 times in a row, then that is a success. All right. If it lands on 5 or 6, it'll be not successful. Okay. So it depends on which numbers you are designating to represent the 2 out of the 3 on the number cube. The spinner. So again, we can have 3 parts, and each trial consists of 2 spins, and a successful trial is the pointer landing on good 2 times in a row, because 2 out of 3. All right. So this is how we simulate that. Now, let us go ahead and quickly do an example on simulating compound events. All right. So again, let's say I have a question, and my question is, a local grocery store sells cereal in 2 packs for a special price. The probability of a box containing a prize is 1/3. Okay, so probability of of containing a prize is 1/3. Okay, design and simulate an event that estimates the probability of randomly selecting a 2 pack that contains a prize in both boxes, and then run the simulation 10 times. Okay, so we said 1/3 was the probability of it containing a prize. So first thing I'm going to do is I'm going to design a simulation. And this is a compound event, because the success of the first event represents 1 box in the 2 pack containing a prize. And the success of the second event represents the other box in the 2 pack containing a prize. So one way to design a simulation is to use a spinner to represent each event. And because the probability of each box containing a prize is 1/3, we are just going to design a spinner like this. Okay, so I have done, I have designed this spinner with 3 equal size sections. You can let one section, such as blue, the blue is going to represent the success of selecting a box that contains a prize. So blue is going to be the success, because 1/3. Okay, so blue is the success, and the other 2 sections represent the failure of selecting a box that does not contain a prize. So both of these over here, because 2/3 means it's failure, because it has to be 1/3. So that would be the success, and the other 2 would be the failure. Okay. So one trial consists of spinning the spinner twice. So I'm just going to show a sample result in a table. Okay, so if I draw out a table, and we said that we are going to spin it like 10 times. Okay, so we have our pack. Okay, and box 1, box 2, box 1, box 2, and then we have both prizes. Both prizes. Okay, and we had talked about spinning it how many times? 10 times, right? So if the one trial comes spinning the spinner twice, um, and let's just spin it 10 times, because that's what the question was. We're going to run the simulation 10 times. So that is why here are my packs: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And if I just make a table like this, and then I conduct my experiment. Okay, and so let's say this is box 1 is this, box 2 no. All right, and here we have our simulations, and I'm just giving an example, and this is correct and no, and 6, and let's do 7 and 8 no, and 9, and then I have 10. Okay, and so let's look at both prizes. Which ones have both prizes that have been selected? So here, no, 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 yes, no, yes, no, 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 and no. So let's look at that table. And these are the sample results which have been shown in the table. Once again, my question was, a local grocery store sells cereal in 2 packs for a special price. The probability of a box containing a prize is 1/3. Design and simulate an event that estimates the probability of randomly selecting a 2-pack that contains a prize in both boxes. Run the simulation 10 times. And what is the simulated probability of getting a prize in both boxes of cereal? Okay, so what we're going to do here, we know that the simulation was how much? We ran it 10 times. And how much was it that we got a yes? So I'm going to circle the ones that have a yes. This one and this one. So out of 10, how many are a yes? It is 2/10. So this is going to be 2 out of 10. Okay, this is 2/10, right? This is also written as 2/10, and I can change this to a percent. Okay, so I would go 2/10 is equal to what over 100? This will be times 10 times 10, that is 20. So 20 over 100, so this is also 20%. It's also 20%. So the estimated probability of selecting a 2-pack containing a prize in both boxes based on the 10 simulated trials is 2/10 or 2/10 as a decimal, or 20%. All right, so that's how we do the calculation. So let's go ahead and do one more example. And in this one, we are going to do an interpretation of, interpret the simulations of compound events. Okay, so let's say I give you a problem, which is up here. Okay, let's say I give you a problem like this. All right, so a computer simulation was designed to simulate rolling a number cube multiple times until all of the possible even numbers were rolled. The relative frequency bar graph shows the number of rolls um, needed for the computer to roll all of the even numbers. So here is my okay. So there is my graph. Okay. So what is the simulated probability that 8 or fewer rolls are needed to obtain all of the even numbers on a number cube? So if I'm looking at this graph, I need to look at 8 or less. Okay, so we have 8 or less. So what we're going to do now is we are going to find the sum of the relative frequencies that indicate that 6, 7, or 8 rows were needed to obtain all of the even numbers. Okay, so let me show you how you would do this calculation. So 8 or less. So we are going to be looking at, probability. Okay. Less than equal to 8, right? And we're talking about the rolls is equal to what? So it's going to be the probability of 6, 7, and 8, because 8 or less, right? So probability of 6 plus probability of 7 plus probability of 8. Okay, and as I can see over here, what are the three probabilities? Okay, so this one, 6 is, right? 6 is going to be my 800th. 7 is 2/10. All right, and 8 is 1200. Okay, so I look at these three, and then all I do is I am going to add them all. So I have the probability of 6 was how much? 800 plus 2/10 plus 1200. Okay, and then when I add all this up, I am going to get 40/100. And 40/100 is nothing but 40%. So this is 40%. And that is my answer. So the relative frequency ratio has the same value as the experimental probability. So the simulated probability that it takes 8 or fewer rolls to obtain all of the even numbers on a number cube is 40%. All right. So once again, this is all about your simulating chance events. Okay. Or simulations often model events that can be difficult, time consuming, or impractical, as I said, to perform in the real life because of the size of that. So that's when we create these simulations. And that this would conclude our module 9 for all the unit on probability. Right. So have a fabulous day, everyone.